Right. So, today's topics are firewalls, as you can see. And we will talk about characteristics of firewalls. We'll talk about different types, where they are located and how they work. And then we'll talk about configurations where we not only use one firewall but actually build up an entire firewall system. And then at the end we'll talk about firewall testing, which is not covered in the textbook but we have here in the slides as well. So, the idea of a firewall to protect a system from some threats from outside. If you go back in the first lecture, we were talking about two different models for network security. So we said that the first model is the communication channel, and we need to protect the communication channel from different type of threats. And then we said we have the second model, which is the gatekeeper function, where we protect system from threats from outside. So the firewall is a typical gatekeeper function. But as we see, we can set up firewalls also to protect on the inside. But we always have this idea that the firewall, we have something behind the firewall that we protect from what is on the outside. But the outside doesn't have to be an external network. It can be part of the internal network as well. And an idea with firewall is that we should be able to protect systems that are themselves not very secure. If you think about a typical organization, we have a number of different type of nodes in that system. We have servers, we have printers, perhaps we have different type of clients, mobile clients, etc. Lots of different types of systems. Each of these systems are at some level of security, but it's very hard to keep a uniform security on all the different devices within an organization. Some will be vulnerable, some will be protected. One of the basic ideas with firewalls is that we put up a protection outside all of these. So regardless of the state of each of us, of a different device we have, we should be able to protect it from outside with a firewall system. So that's one of the main goals with a firewall, to be able to protect items or devices that are not very well protected by themselves. So we try to put up a firewall between the system that we protect and the threat that we have. And of course the main threat is the internet, an outside network, but it could also be other things. Some fundamental ideas here that we need to establish a control link, because now we have an outside and we have an inside. They need to be connected, and potentially they could have several connections. We could have several different ways to get into the network. If that is the case, then it makes it much more complex for us, because we put a firewall in one of these connections, and that's where we control it. If there are other ways around it, then the security is of course not so great. So we try to establish a controlled link. There could be several, but in that case we need to make sure that they are equally controlled in the same way. But we try to reduce the control links at least. So hopefully a single choke point. If not possible, we might have a few, but not very many at least. So it's at this control link or control point that we put the security. Of course, that point is open for threats because that is at the perimeter of our security. All the threat that is coming from outside will of course reach the firewall itself. The purpose of a firewall is to stop them from going into our system, but the firewall itself is not protected. So another important principle is that the firewall itself should be a very high secure system that couldn't easily be attacked. And there are different ways to implement it. One way is to implement it in something we call a trusted system. For those who took the computer security course, we talked about trusted system in that course. There are different design principles we can have for a trusted system. But the idea is that we should be able to control all the different actions that is going on in the system and make sure that they are not escalating priorities or something like that. So that's another principle that is important here. There are limitations as well with firewalls, and here we see some of them. We cannot protect, of course, attacks that is bypassing the firewall if there are ways around it. And often there are different ways around it. And we see some. There could be a dial-up service that makes it possible to get in. That is not going through the firewall. It reaches a point behind the firewall. We could have trust organizations. We have an extranet. We have other organizations around the network that we share resources with. And in order for that to work, they are probably tunneling in. So we have some type of VPN solution. And that may also bypass the firewall. There could be specific trusted service as well that is also tunneling through the firewall. We talked about that when we talked about SSH. That one of the main ideas with SSH is that it should be able to actually penetrate, go through a firewall to make services available from outside. So there will be traffic flows that can be hard to actually do something about with the firewall itself. Instead for these, of course, we have to manage them separate to make sure that they are secure in themselves. Second point here, internal threats. There will be insider attacks. And the main idea with firewall is to be at the perimeter, so any inside attack will, of course, not be stopped. But we can handle that by dividing up our internal network in subnets and then have firewalls between the subnets so we can in some way at least minimize that problem. We can also handle it by putting firewalls in all devices. So each device also have a firewall. We'll come back to that when we talk about firewall configurations. We can have wireless LAN. That would typically be another way to get in. You connect through a wireless LAN, and it's easy to connect to a wireless LAN, so we could have attacks that way. And then any threats, any malware that is imported with other means, USB memories, someone bringing in and connect the computer to the network that is already infected malware. Now we have it. We have bypassed the firewall. So of course there are a lot of threats that firewalls couldn't handle. We'll talk about 4 different techniques for a firewall when it decides what type of traffic that you should allow to go through or should be deleted. So the first one is service control. We determine if some package should go through dependent on what type of service it is. So for instance, if it's email, we may allow it. If it's HTTP, we may allow it. But if it's some file server, peer-to-peer service, whatever we could drop it. So based on what type of service it is. Direction control, in what direction the traffic is flowing. We may stop most traffic that is going in, but we may allow most traffic going out, for instance. Then we have user control. So we base the decision on who is actually behind this traffic. If it's a trusted user who is authorized to do this type of traffic, we allow it. If it's another user, we don't allow it. And then we can have behavior control, which is the most complex, because then we need to go in and follow the traffic to see what it actually means. If it's an email, for instance, we can follow the traffic and see, okay, is someone trying to get in an attachment with some malware in it? If it's some type of web traffic, we can follow the session to see if someone is trying to hack into the web server by doing different things, and then we can stop it based on what we do. Each separate thing may look okay, but when we look at it from a behavior point of view, following it, we can see that this is malicious and we can stop it. So any firewall can use just one or a combination of these techniques when we are deciding on what traffic to allow. Different scopes of firewall. Well, first we have the major difference here between personal firewalls or host-based that are just for one device, often connected or even part of the operating system. These are almost always software implementations. So they run as a service with some benefits and problems that will give. We'll come back to that. And then we have other types, site or hardware-based, which are dedicated devices that we put into the network, connect input-output interfaces, traffic is going through it, and it's a dedicated device just for firewall. The most of the discussion here will be on site firewalls or dedicated firewalls. So if you look at that type of firewall, we have three common types: packet filtering, application level, and circuit level. They are all firewalls. They are using different combination of the techniques we talked about, so they are more or less complex to implement, and they have slightly different purpose. When we also will talk about firewall configuration, how to build an entire system of firewalls, we will also include something called a bastion host in that. The bastion host is not in itself a firewall, but it can be part of a firewall system. So let's start with packet filtering. That is the normal type you think of probably, and the easiest one to implement. So we have an external network, we have this packet filtering router and a private network, and all the traffic flows through it here. And typically when we look at what traffic should be allowed to go in either direction here, we look at these three layers in a protocol stack. We look at the network access, which will tell us which interface was used, which physical interface. We'll talk about the internet layer. So now we're talking about IP addresses, which means that we know which host created that traffic and where it's destined to. And at the transport level, we look at the port number, so we can see what service we're using. So mainly we take a decision then a packet arrives, we look at, okay, what interface did it arrive on, what IP address did it come from, and what port, and where it is going. And then based on that, we either discard it or allow it to pass. Sometimes we skip the transport part, we just look at the IP addresses. So it can vary, but often we use a combination of those. So what we do in the firewall then is we have a set of rules. And these rules should follow some policy. So we have, again, to go back to a security policy for organization, talking about what type of actions are allowed for users of this organization. Are we allowed to go and surf on any web page or not? Are we allowed to use private email while we work inside and access another mail server somewhere? Or are we only allowed to use the internal email system, and so on? So we have these policies, and now we can try to apply those as rules in our firewall to decide what type of traffic to allow and what to drop in. And as I said, it goes both directions, so we can look at both incoming and outgoing traffic. And there could be very different rules for incoming and outgoing. We can have two default policies. Yeah, question.
You said here, firewall, according to the interface and IP enable, we allow all of that. But why we don't use, like by default, everything not allowed, and according to our need, we allow some.
Yeah. Well, that's actually exactly what I come now, the default policy. We can have two main ideas for how our firewall will work. The main idea could be to discard everything unless we have a rule in our rule set here that explicitly allows it. So in that sense, our base rule is discard everything, and then we can specifically add rules for what we allow. Or we can turn it around and say that, well, we have a very forgiving policy. We will allow anything except things that we know are malicious, that we would like to drop. And of course, depending on which policy, main policy here, it will be very different for the users. If a main policy is discard everything, we will not be able to do very much. And if you want to test something new, it will not be possible unless we can convince the firewall administrator to add that, to allow that as well. If we have the forward policy instead, we can easily do new things. But we're also more open for attacks, of course. As soon as there is an attack that we don't know about, that we don't block, the firewall will be open for that attack. Which of these policies do you think is the best in general? Yeah.
Discard everything and set exceptions.
Discard everything. Okay.
And set exceptions.
Yeah.
What you want to allow.
Mm. Anyone have another opinion than discard is the best?
Doesn't it depend on what you want to look at?
Yeah. So your needs. Yeah.
Depends on what you want to do. If you're in a factory, for example, it's very easy to just discard everything because you know only your control mechanisms should have a connection. But if you're, for example, a software development company, then it could be very bad to just discard everything.
Yeah. Good point. So it depends really on what is behind the firewall. As I said, if it's some type of industrial plant, there's no reason of being able to explore different things. We should be very strict. On the other hand, if it's a university behind the firewall, we want to be able to explore different things and test different things. So in that situation, a forward policy is probably better. It's not as secure, but it works better the type of organization you are. And if you look at the firewall we have here at the university, it is quite open. It only stops a few things that are known to be malicious or can easily be used to exploit things. Otherwise, things are open. But there are actually a little bit different now for students and for staff. So students are blocked a little bit more than staff. So, examples. Well, we could have say a policy that we shouldn't have outside web access, because then staff is just looking at newspaper sites or looking at Yahoo videos or whatever, or YouTube videos. So then the firewall setting could be drop all outgoing packets to any IP address on port 80. How well would that work if we implemented that way?
Super well.
Sorry?
Not super well.
Not super well. Why not?
Because there's also HTTPS.
Yeah.
Port 443.
Exactly. Most ports sites today are not using port 80. They're HTTPS 443. And if someone would like to bypass it, they can just ask the website administrator to use an alternative port, and then we can bypass the firewall. So it's not so easy to come up with how a rule should be to actually implement that policy. We would actually for a normal packet filtering firewall is probably not possible even, because we really need to be able to inspect the traffic to see if it is something that look like web traffic, whatever port it's using. This one then, outside connections to the public web server only. So we should allow someone to go out, but we shouldn't allow people to anything else. And then we say the firewall setting drop TCP SYN packets to any IP except a certain IP on port 80. Okay, sorry. So the policy is that people on the outside should only be able to connect to our web server, nothing else on the inside. So this would probably work better then as a rule, because it will drop anything except someone going exactly to the web server IP and the port 80. It's more strict and it will be more probably to actually work. Other things we can do is to see prevent web radios. Well, that's UDP packets. So we drop UDP. Of course, this will drop a lot of other type of traffics as well. So to work, we at least in the setting here we say that, but we shouldn't drop DNS packets because we actually need to be able to reach DNS servers. But probably would have to work much more finely here to decide exactly what type of UDP we need to allow more than just DNS probably. And so on. So we can just see these are examples of rule sets and the problem of actually implementing a policy as a rule. Yeah.
This like searching for special packets would still work if we encrypt our organization.
Encryption of traffic is a complication here. Especially if someone is trying to bypass or tunnel through the firewall with an encrypted channel. So the ways to deal with that is, of course, to just not allow encrypted traffic. That is one option. Another option is something that is used in quite many organizations today, and that is to end an encryption in the firewall and then create a new encryption firewall to the other system, which makes the user think that you have an encryption all the way. And so it's sort of a man-in-the-middle attack actually that the firewall is doing on you. But since the firewall is part of the organization, and has a certificate, you probably trust it, so you allow it to do that. And that is actually quite common today. So if you have, that is, for instance, universities doing it. If you have SSL connections to different servers outside, they will actually be decrypted in the firewall. So there are different ways, but if we allow encrypted traffic to go through, then things can get through without the firewall being able to do anything about it. So that is an issue. If you go in more precisely in the firewall, these are the rules as they can actually be in the rule set. So we say that we have a number of rules here. Whenever a packet comes, we start to match them, and we continue until we find a row that is matching, and then we are executing that rule, and then we take the next packet. So if you look at this rule set, we say that we have a number of allow rules here, and if none of them matches, we have a default that is deny. So this is a conservative firewall. We wouldn't allow anything that isn't explicitly allowed here. So if you have a look at the rule set for a while, what will this firewall allow? Yeah.
TCP and UDP traffic from normal ports, like non-vital ports from that whole subnet, like from that whole network.
Web and DNS.
But what does it mean? What would it actually be in terms of type of traffic? Yeah.
Basically, we allow any TCP package from outside of the firewall, and but we don't allow anything going out other than the acknowledgement for TCP protocol.
Well, not anything going out. That's it.
Web and TCP traffic.
Sorry?
Web and TCP or DNS traffic.
Yeah. That's what we were handling. Web, we allow web and DNS. So the first rule here says that anything from outside going to the outside, TCP port 80. So as long as we connect to a web server outside, our source port is above, because whenever a client connects to outside, we take a random free port number above 1023. So we don't know which port the client will use. So we have to allow any port number here. So we allow anyone to try to connect to a web server outside, and we have to allow the traffic coming back. So when that web server is sending something back, it will be as an acknowledged packet, and that has to be able to go back. And the other two, we are allowed to connect to a DNS server on port 53 using UDP, and we allow the reply to come back. So that is something that you often have to think about when you set up these rules, that you have to think about, well, when you initiate traffic in one direction, there will be something coming back as well, and you need to think about rules on both directions. Some possible attacks on packet filtering firewalls. First one is address spoofing. You add a fake source address, and if, as you see in this example here, we don't look at the interface. We don't see which interface the packet came from. So if someone is sending a packet claiming to be from the inside, it will pass as an inside packet, even if it's not. That means we can reach a computer on the inside, but we are not meant to be able to reach from the outside. That could be used as an denial of service attack, for instance. Of course, we couldn't reach anything on the inside and get the traffic back, because the traffic wouldn't be routed to us since we have a fake address. But we could do an attack on the service at least. We can handle that by also filtering on interfaces, so we can see that someone from outside is trying to use an internal IP address, for instance. Another area is called source routing. You know, source routing is an option that we have in IP. Normally, we allow to routers to decide how to forward a packet, but we have these extension headers in IPv6 or the normal headers in IPv4 that makes it possible to do source routing. We decide how the packet should be routed when we create it. And that could be a way to actually go around the firewall, because we are mirroring the traffic through the router, who is a trusted device. Source routing is something that is not often used, so we can easily block all traffic that is using source routing and say that, well, it's not allowed. And the third type of attack is called a tiny fragment attack. We fragment our packet into tiny fragments, so small that not even the header fits in one packet. What happens then? Well, if we don't have the entire header, we don't have all the information about port numbers, IP addresses that are used. So when we make a decision in our rule set, we couldn't decide if it should be allowed or not. And if we then have a very forgiving rule set, we will allow anything that we don't explicitly drop. So it will pass through. And then once they are inside, they are merged, of course, normally, as fragments are doing, and then it can go through. So ways to handle that is either to discard these tiny fragments or to reassemble them already in the firewall, which is not as it should be according to IP standard, but we can do it. It will work. Some advantage with this packet filtering. It's simple. Users doesn't need to know about it, so it's transparent. We'll protect them. What they will see is that some traffic will be blocked. So that is, of course, not transparent, but they won't have to do anything. And also, it's quite efficient. It's high speed. Some disadvantages, as is already seen here, it can be quite tricky to come up with a rule set that is actually matching the policy that we are thinking that we want to implement. Yeah.
How do IPv6 firewalls deal with the follow-up header?
The extension headers.
Yeah, the extension headers of IPv6. So they just wait for all the headers to come, like they were doing in the
Well, in IP version 6, as I said, we have these extension headers, and typically a decision should be based on all the headers. Normally, that is not a big problem because the header should fit it within packets or one fragment, even for IP version 6. I mean, there are some extension headers that are very big, but very few, and you could just disallow fragmenting the headers even in IP version 6. So creating the rule set can be quite tricky, and the second thing is that you don't have authentication. You don't know who actually is behind the traffic. You have no proof who it is. The only thing you have is an IP address and a port number, but who actually created this is unknown to us. with packet filtering, we can go one step further. What we talked about so far is what we called stateless firewalls. And with that, we mean we don't have any concept of a state or any history knowledge. When we look at the packet, we look at it on its own merit. We either allow it or not, based on the rule set, but we don't know what came before. But we can also implement what we call stateful firewalls. And then we do know that there is a history, that the packet is actually coming as a stream of packets and they belong to a session. And then we can make more precise decisions based on what type of session they belong to. So stateful is more advanced, and it requires us to have this state information somehow. Well, we can actually go through here. So what we need is something like this. We need to have information about current sessions. So whenever someone establishes a new TCP session for the firewall will look at the three-way handshake and say, okay, now is an established connection. Of course, we can already here block it if it's not allowed. But if we do allow it, we know that now there is a session here. And then we notify it here. We say, okay, there is a session going on from inside to some destination, and the port numbers on both sides, and the timestamp when we last saw a packet following this session. And then we can have a timeout. So if nothing happened for 60 seconds or 5 minutes, whatever, we drop it here. Remember the heartbleed protocol for HTTPS. This is exactly why we have that heartbeat protocol, to allow a firewall, stateful firewall, to see that, okay, even if the user is not doing anything for a couple of minutes, we have to keep the session open here. And then our rules also can now include this concept of an active session. So if, for instance, there arrives a packet from outside, source address with IP address port 80, and it's destined for a computer on the inside. Now we also have these flags. So we can follow the session here. And here we see SYN is 0, so it's not a handshake. Handshake is already done. But ACK is set to 1, so it's actually a response from a request here. And then we have a rule saying, yes, we should allow someone from outside here to reach any computer on the inside. If we're using this port 80 and it's an ACK, but we should only allow it if we already have a session here. So if we haven't negotiated three-way handshake between those computers before, there's no reason for why they should arrive and reply here. So then we should drop it. But now we can go back here and check. Yes, there is. Well, which one was it? Yeah, the first one here. We do have an active connection here, so now we allow it. Yep.
But if you basically know every connection that's going to the firewall, and you basically track it. So we don't just check if it's valid, we also track it at this point. Wouldn't that mean that we would spy on everyone who's behind the firewall? For example, if you're a company and we basically spy on everything that our employees are doing over the internet, would that be legal?
Well, you could say that the firewall is a spy device because you are looking at all traffic, but you're doing that regardless of if it's stateful or stateless. I mean, you do inspect each packet. If we look at what we have seen so far, the packet filtering, the only thing we look at is metadata. We don't look at the content of a packet. So we don't spy on what is going on, just the type of traffic that is going on.
You can do a lot with metadata these days.
Yes, you can do a lot with the metadata itself. And we talked about that when I talked about intruder behaviors. So we can say that we could have this disgruntled user on the inside that is contacting a server outside, submitting information, whatever. Yes, that is something we could find out about here. Is it allowed? It's allowed to set up a policy and say that certain traffic is not allowed or not. You can decide that. It's your network. You decide what type of traffic to allow. If you go one step further and say, but now we notify this traffic, we didn't only drop it, we put it in a log as well, and now we follow up on that log. Now you're getting into territory that is more of a gray zone, for sure. Maybe illegal. But just look at the traffic and either dropping it or allowing it. That is completely fine. This type of firewall, of course, will be a bit slower because you need this database with sessions, and for a site firewall, for an organization with thousands of users, each user having lots of sessions going, it's a lot of data that you need to keep active and check and so on. So it will slow down a little bit, but it's not really noticeable. You can implement it quite efficiently anyway. So that was the packet filtering. Now we move on to the second type of firewall, which is called application level gateway. And as you see, this is quite different from a packet filtering, because now we are typically working at the application level of a protocol stack instead. Which means that, okay, we still have an outside host, we have an inside host, we have the firewall here, but now the firewall knows about different application level protocols. And whenever someone on the inside is connecting to the outside, we can follow that protocol because we know exactly how that protocol works. And that means we can allow specific behavior on a protocol or deny it. Not only based on who is communicating, but actually exactly what is going on. This makes it possible for open up some services on the inside that we otherwise wouldn't allow to have open because they are too easy to hack. But now, since we can follow exactly what's going on, as long as people on outside is doing the normal behavior, we can allow it. As soon as we start doing something that is more hacking, we can stop it because we know exactly how the protocol should work and whenever it is possible that it's vulnerable. So that's the idea with the application level gateway. We also call it a proxy server because you send your traffic to the application level or the proxy server who is processing and then passes it on. And actually you can use proxy service for other things as well, not only for the main purpose of being a firewall. You can do it by adding extra services in the proxy and so on. But in this context, we'll look at it as just a firewall. Some advantages with application level. It's high security because you actually know what's going on. So you can much more precisely decide what to allow or what not to allow. And we only implement it for a certain application protocols that we decide we should handle. So we don't need to cover all the 1,000 application protocols that are out there. We only have to implement the ones that we are actually supporting. But that also have a negative side, because what about the ones that you don't support? Someone is now trying to start using a new application protocol. How should we handle that? Suggestions? Yeah?
Take forever and then speak to the IT team and then make them implement.
Yeah, but that would take time to ask them to implement a new one. It could take weeks or months perhaps. And what do we do in the meantime?
You sit around, drink coffee.
Well, we have two main options here. If not supported, then one option is to just drop that traffic. The other option is, of course, to allow it without an application level gateway. And possibly just filter it using a packet filtering firewall instead. So for certain protocols, we go through the application level, and then we can allow some protocols that are not secure enough for packet filtering, but the rest of the traffic we handle with normal packet filtering. So we can balancing it out in that way. We don't have to delete everything else. And then we have the third type. It's called the circuit level gateway. Yeah.
Can you show us like example how the application firewall works? Like
how this one would work. Yeah, well, as an example, it could be that we use an HTTP proxy. So, in order, we say that in our organization, in our network, you're not allowed to access public web service. We block that. But it is allowed if you use an HTTP proxy. So that means whenever you try to go out on the internet, you actually have to relay that to the proxy instead. And then the proxy actually contacts the web server for you. And then make sure that nothing malicious is coming from that web server and threatening you. So for you, what you need to do is you have to tell in your configuration on your machine that I will use a proxy. I will go to another machine whenever I go using HTTP traffic. And after that, you won't see much of it because most of the traffic will be just relayed, so you will have it a little bit later because it takes some time. But most of the traffic will just get passed by the proxy. But as soon as it sees something malicious or threatening, it will block it. So that's in practice how it will work for you. So circuit level is, as you see, working again on the transport level. And the idea with it is really to isolate you from anyone on the outside. So the idea is that you on the inside here, you initiate the connection. You say, I would like to have a session to a certain computer somewhere. Of course, now we are at transport levels, we're talking about sessions then. You send that to the circuit level gateway, who then decides if that session should be allowed or not. And it can base that on whatever information it has. It can be based on who you are, what type of service it is, when it is on the day, or whatever. But at that stage, it makes a decision if it should allow it or not. If it's allowed, then it creates its own session with that server. So that server outside is really thinking that we are communicating with a gateway. And then, so again, it works as a man in the middle, you can say. And then it just relays. So if we are allowed to create a session, we just relay the communication here between them. So the real security is that we decide if we should allow that session or not to be created in the first instance. And then once it has been established, we don't have a direct connection. So this outside host have no way to attack this machine other than through the session we have allowed. We are not vulnerable for anything else. We are separated, isolated from any other type of traffic. Of course, again, we could combine this. So once we have this session going on here, we could have a packet filtering firewall that is is filtering that session. But the main aspect here is to allow or not allow that session to be initiated and then work as a relay. So the circuit level gateway is a standalone. It's sort of a proxy system that as well. And as said, it works as a man in the middle. It initiates sessions with both inside, outside, and then just relays them. And the security, as I said, is mainly to determine if a connection should be allowed or not. An example of this is called SOX. That is a standard open solution for this type of gateway that is supported in many operating systems. Before we take a break, we'll just mention the Bastion host as well, which could be part of a firewall configuration. It's not a firewall itself, but it serves as a platform for typically application level or circuit level gateway. And a Bastion host itself should also be what's called a trusted system. It's a system that it's very hard to hack because it's built as a trusted system. So let's take a break now for 10 minutes or 9 minutes perhaps.
Yes. I don't know. Depends on how happy the teacher is. I have 4 questions answered, which I have right. So that might be a pass. But the explanation of one of the theory questions was a theory question. I know I have it right, and the reason is whatever the numbers, but I don't know if my reasoning was properly explained. Right? So that could make it or break it. But then I did 2 other questions that were half-assed because I didn't really know how to do them. That might give like 1 or 2 that takes away from the other ones. I'm like borderline. Someone tried to hack my Steam account, running the children on my password. My Steam card, because my Steam card is prompting me to the code. Yeah, the code given the code. I mean, to be fair, I made the password when I was tech. Like, back then, the security requirements were like, you should probably put letters together. So, yeah. Have I been wrong? Really? Have I been wrong? I mean, obviously not. What website did you go to? Oh, okay. In the email I never use anymore, I've been using it for some time. But the password is the only one I use. I think the email is more important than time.
almost
ما
same
هذا
thing.
السيشن يعني شو السيشن يعني؟ ما كيف نمنع السيشن يعني بناء على ايش؟ يعني شو القيم بتاعت السيشن اللي قبله؟ السيشن ايش؟
ناخد بس افكار او بعدين الحياه العمليه تفهمها لما ترجع تكرر ذاكرتك. Yeah, because you're close to you don't care about this part of them.
طب ليش هالباب ما اشتركتش يعني؟
ليش أنا application عندي application خطوط على
Yeah.
طب ليش هيقول لك يعني ما بتشترك يعني؟ ليش يعني؟ وإذا لينكس ولينكس مختلفين.
Var det mycket folk eller? Alltså, jag gick mycket liksom. Var det 700 pers? Eller liksom?
Okay. So, a few words on host-based firewalls. Software module, as said before, often part of or working together with operating system. Can be used in any type of clients. Can be small mobile devices or servers or whatever. There are some advantages with host-based firewall. Well, first, of course, if we have them in all devices, we have lots of protection in terms of firewalls all over the place. So that in itself could be interesting. But you can also know things about the system that it's running in. So it knows, okay, what users are active right now, what applications are that user running. Does it seem okay to have this type of traffic based on what we're actually doing in the system? So that makes it possible for us to stop attacks, because we know that is something that shouldn't go on right now, because we don't have a user who is actively doing anything like this. Also, it will protect the device regardless of what type of infrastructure we are, if our main firewall is actually protecting us or not. I mean, if we move our node outside that protection, we are still protected. And as long as we are inside, we have an additional layer. Now we have both a site and a host firewall. Personal firewalls are the typical example of host-based, even if host-based could be others as well. We talk about host-based in devices that are not normally personal devices. But personal firewall, then it's the normal that you're all using on different types of devices that you have. Sometimes we also talk about personal firewalls. Actually, if we talk about the device that you have to connect to internet at home, you have some type of fiber router or DSL router, whatever, which also typically is holding an access point to a wireless network, and a firewall, which is typically normally a packet filtering firewall. Primarily, these are in order to protect from outside, for different types of attacks from outside. While site firewalls, host-based or site firewalls, also looking at traffic from inside and see what is something that we should allow from inside. So this could be a typical setting for a personal firewall. It's active, and then we are describing what type of services that we should actually allow, so we can configure it to our needs here. You see, this setting doesn't allow very much. Nothing is really turned on, so we don't allow any traffic typically from outside right now. But if we would like to have, for instance, remote login with SSH, we could allow that, and then we can have a secure tunnel in. But now we have these different types of firewalls. Let's see how we can build entire configuration with these building blocks. And of course there are endless ways to do that, but we'll look at 3 types of configurations. So the first configuration is called screened host firewall system with a single homed bastion host. Okay, so what do we have here? Well, we have a packet filtering router. We have some service that should be publicly available. We have some servers or clients on the inside, and we have a bastion host that could support, for instance, a circuit gateway or application level gateway. So the idea with having these two devices now is that in the packet filtering router we set up rules to say that if you would get on from outside reach something inside, that will only be allowed if you go to the bastion host or if you go to one of the public web service. If you from outside try to directly contact something other on inside, it will be blocked. So you need to go through the proxy in order to get to the inside. And that way you will have two levels of defense then on the inside host. They need to go through both the packet filtering router and the bastion host. These public servers are more vulnerable, but they are also something that should be easily accessed from anyone on the outside. So you can reach those directly just going through the packet filtering router. The single homed part here is, as you see, that the bastion host only have one network interface. It's connected to the inside network. As you see, we have just one inside network. Everything is connected on the same network here. So as soon as you're inside, you can reach whatever you want. Well, we already said that. And we said that the packet filtering router will only allow to the bastion host or to the public service. The bastion host here can do authentication from inside or from the outside. Someone wants to get inside and they need to authenticate in order to be allowed to go in, and do different type of proxy functions, filtering or whatever. So this configuration gives better security because we have two systems that we need to bypass when to get in. But it also has some limitations. And one limitation is that as it is set up now, imagine that you are a hacker and you would like to reach a client here on the inside. How would you do? What would you try to hack to get to the inside?
Packet filter and the bastion host.
Well, you could hack the bastion host, or you could hack the packet filtering router. You could reach the bastion host from outside, so you could try to attack that. And if you are successful, then you could also get in. But you can also just bypass the bastion host by attacking the packet filtering router. If you can do that, it can allow you to go directly here, bypassing bastion host. Yeah.
Also call the private network owner, the owner of the computer we want to hack, try to get him to open the door for us basically, and then attack from behind. So that we come from the inside and don't have to...
Yeah, an inside attack is always more successful. But that will be possible in any firewall configuration typically. So assume that the threat is from outside now. So to try to mitigate that problem, we can do it in this way. What's the difference here between this configuration and the previous one?
Two interfaces.
Yeah, we have two interfaces. So the bastion host have two interfaces, and as you see, there is no direct connection. So what we have now is actually three different networks. We have external network, we have an internal network, and then we have something here in the middle, but it's not directly connected to either of them. So if someone tries to do the same attack as before now, we attack the packet filtering router and we compromise it. What can they do? Well, the only thing they can reach is the bastion host and the public service here. The inside network is still protected. We need to also get through the bastion host to get in. So this is a more secure version of the previous one then. And then we have a third example here. Now we add one more packet filtering router. So now we have two packet filtering routers, and we will have a Bastion host. So what we have done is really we have made it even more clear that we actually have three types of networks: inside, outside, and something here in the middle. And both of them are separated by these packet filtering routers. So someone from the inside who want to go out first have to pass the packet filtering router, go to the Bastion host, get clearance here, and then get through the outside packet filtering router as well. And the same way, someone from outside need to get through 3 levels or layers of defense to get in. Of course, the servers or whatever that is in the middle network here are more exposed, but they're also something that should be available from outside. And that means we have to work on those hosts to make them what's called hardened, to make them more resilient to attacks. This third network, the middle network, we often call a DMZ network, a demilitarized zone. That is a zone that should be accessible, and it should be a sort of a neutral zone. So there we put typically things that web service, email service, DNS server, things that should be available from outside. But of course also something that we should be able to access from the inside to manage them. But systems that we normally work with day to day is in our internal protected network. So they're not accessible from outside unless we go through this Bastion host. So this is a typical solution with firewall today, to have this division in internal, external, and DMZ. Now let's add also what we call a distributed firewall system to this. And in the distributed firewall system we manage all the firewalls in our system. So we have our normal site firewalls that we can work with, but we also have this host-based firewall in the different systems. And to be called a distributed firewall, we need to have some type of management control over all of them. So we can, from a central station, we can push out a policy to both host-based and site-based in order to change the behavior of what type of traffic should be allowed in and out and so on. This of course will be even more secure, because now we have to also penetrate the host-based firewall, not only the site firewalls. In most situations, these distributed firewall systems is not really working perfectly aligned. We have configurations so we can work with the hardware firewalls as one system, but then we typically have another system to manage the host-based. And of course a problem here is that there are lots of different types of devices, and all devices doesn't support the same product as a software-based firewall. So we probably need to use different software-based firewalls. And then it's hard to come up with a tool that can manage them all together. So there is no perfect solution here, but this is an ideal picture of how it should work. We can also merge different types of functionality. If we now have a firewall, what else can we do in that firewall? Now we're talking about one of these boundary hardware firewall. So we put a firewall here. What should we put in it, except for just filtering? Well, there are different ideas what we can have. We can have VPN. It's a good reason to put the VPN together with a firewall, because a VPN tunnel should end at the firewall. After a firewall, the traffic should be unencrypted and in the internal system. If it should end, in this situation, if a VPN should end here or here or here, depends of course on what type of traffic you have, what the aim of a tunnel is. It can end in any of these. But it's a good idea that it ends at the firewall, because after a firewall we have a protected network. Intrusion detection, intrusion prevention could be a good idea, especially if you have intrusion prevention, because then we said that we see an attack and then we would like to try to stop it. And then if we work with the firewall together here, we can easily update the firewall rules to stop an ongoing attack. But regardless, if it's an IPS, it's a good way because we see all the traffic going in and out, and we can see both the traffic on the outside and on the inside, and that may be a good idea for an IDS to be able to see both versions of traffic. NAT, what is that? Network address translation, yeah. And what's the purpose of NAT?
It's for public IP to look at.
Yeah, we have outside the NAT, we have a public IP, and that is what we are seeing. But on the inside, we use private address, and then we translate the private address into public address whenever we go out on network. So again, I mean, this is the point where NAT should be applied. In the internal network, we have a private address, and outside the firewall, we have a public network. So it's really in the same point. Routing is the same. I mean, we need to route traffic here. We have different networks we need to route. So it's an obvious service to also have together with the firewall. Authentication, well, depending on the firewall system, we may need to authenticate, especially if we have VPN together with it. We need to authenticate in order to go in and out. But we can also have a firewall that only allows traffic if it's for a certain person, so we need to authenticate just to the firewall itself. So again, that is something that could be here. And if you look at the type of device you have at home, as I said before, you typically have a wireless access point as well. That is just another network interface then, really. So these devices can be quite complex. You can have lots of different things going on inside them. And there is a range of possibilities. There are dedicated firewall that is just the firewall, and then you have some devices that have all of these in one device, or any combination of it, really. Well, this is just an illustration of if you have a firewall and the VPN together. Here we have a single user who calls into the network. Everything is encrypted until it arrives to the firewall, and here the tunnel ends, and it's relayed inside without protection, but also filtered then. So, to sum up all the different possibilities, here we see just different ideas on how to build the firewalls, how to combine different systems. So I don't go through them now, it's just really a sum up of what we talked about already. Now, we have started from a policy. Policy said we should allow certain type of traffic, we should drop other type of traffic. We have made a decision on what type of firewall to build, the firewall configuration, what other type of service to include it, and we have implemented it. What we have now is a very complex system. What we need to do is test to make sure that it actually is doing what we are expecting it to do. So firewall testing is extremely important. So how can we test the firewall system? Well, here you see some things that we should test for. We should test that the supported ports are open and other ports are not open for traffic. We should test the reliability of it. We should test that we can administrate it from places we would like to be able to administrate it from, if it should only be local or remote administration. If we allow remote administration, that has to be very secure. And typically, if you look at firewall system or any type of IT system that you are actually allowing to administrate from outside, you typically use SSH to create a secure tunnel to that system from outside. But if it's high security, you won't allow it to be able to be administrated at all from outside. So you need to actually be on location to do it. But what needs to be tested? Well, here we see some things. The host hardware, we need to make sure that it's actually running. Memory is working, hard drives is working, interfaces, so nothing is broken in the hardware part. That is, we can typically see quite easily, but some problems are more silent, so we need to make sure that we can catch them. On that hardware, we run some type of operating system. Even these hardware based firewalls that are just a firewall, what you have is the basic hardware, and then you have some type of operating system running on that. Typically can be some Unix based, or it can be a dedicated operating system just for a firewall. But you have things running here that is used in order to boot the system, to be able to update it, to allow different types of administrations on. Here you have possible bugs in the operating system. You have to manage it, make sure that it's up to date. Then you have the network. You have all the cables, switches and so on. That also need to work. You remember this incident that many of you mentioned in your pre-report as well about the 1177 incident, where people called in and they recorded the conversation and had it on a hard drive, and then someone connected a hard drive. It was quite fun how they wrote about it in technical. They connected the hard drive to the net and suddenly everyone could access it. That was because they connected on the wrong place here in the network. So it's not only that you have a working network, but actually that it's still is working as it should do, so people don't reconfigure, put the cable where you shouldn't put it. And then we have a firewall configuration itself. We've seen that just for a very simple situation, we need several rules. For a normal situation, we need more rules, and making sure that the rules are actually doing what we think they should be doing. And that configuration file, log files is working. If the system is rebooted, that actually loads a correct configuration again, so it's not an old configuration that is loaded. A lot of things that we need to test. Exhaustive testing isn't possible because think about the combination. We have a network with maybe thousands of computers. Each of them have thousands of possible ports. There are thousands of possible protocols. To test all combinations of this just explodes. It's impossible. What we try to do is instead to find the interesting boundary tests. And a typical boundary test would be, we have an internal network, we start with one IP address and end with another IP address. We should test the boundaries, that the first address is working as it should, and the address before that is not allowed because it's not part of it. And then the other boundary end. And then maybe we should some random addresses in the range as well to see that it's not only the boundary that works, but also the range within the boundary. So we should devise these tests that are sensibly testing interesting aspects of a network and the possible ways to get in. So, well, I think we should test the configuration, the filtering rules itself, hardware, software of a system, both in normal conditions and abnormal conditions. That is also an important aspect. A normal condition is maybe then we have a network load of 5–10%. But what happens with a firewall if we are under a denial of service attack and we're up to almost 100% capacity of a network? What happens then? Well, some firewalls will start to just let traffic bypass because it doesn't have time to handle them correctly. So you have to make sure that it works in all conditions. Do you have a question? No? 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 To do this, we need tools. We couldn't do it manually, but there are many different types of tools we can use. Network traffic generators. We need to be able to generate the type of traffic we would like to test. If someone from outside, we would make sure that that type of attack doesn't work, or that type of traffic we will not allow. We have to make sure that we actually can generate that traffic from outside and make sure that the firewall will actually block it. So there are different types of generators. On the other side, we have monitors to see what is actually going on. It's not enough to see that in the log of a firewall it says, okay, there came a packet from that machine, it was dropped. It says in the log it's dropped. Actually, it may not be dropped even if the log says so. We should look at the traffic coming out from the firewall with a network monitor to see that there isn't a packet. We can use port scanners, quick way to check that all the ports that should be closed are closed. Different vulnerability detection tools that can make more complex attacks. For instance, especially if we have these firewalls that are working on gateway or application level, these tools can help us make sure that they actually work as they should. And we can also use intrusion detection systems. We can put that next to our firewall, and then when we are doing different tests, we look at both what the firewall is saying and what our intrusion detection system is saying to make sure that they actually see the same thing and have the same view of what's going on. So there are a lot of tools we can use, and most of them you should use. So that was actually the last slide, which means we'll have time for a Kahoot then. Let's see which one we should go for.
Time for that music.
All right, let's go for this one.
Well, if not, see your answers.
I see a web server signed in. Or two actually. But that one didn't have any page. Okay, so this will be a more general information security Kahoot. With some questions from different fields that we have discussed. And not so complex. Okay, anyone waiting for? Or is there one in? Okay. Let's see. 9 questions. Okay, good. Well, I guess a few were a little quick with the access there, otherwise it's correct. But it's not well, it is the CIA, but it's not in this term. 9,000, so it's ISO qualified. Okay, next question. Sending unwanted bulk message. Okay, if you also putting unnecessary load on the network, well, it will, of course, because any spam email is unnecessary load, but it's not load that is a problem for the network normally. I mean, it's not a denial of service attack. To do that, you have to send lots of spam, and then it's probably classified as something else than just spam. Okay, a change here in the top. Next one. Good. Well, both special characters and, as long as we already talked about that before, are valid options, but length is the main one. So good. Again, a change in the lead. It's very close here on the top. Okay, next one. Okay. So 5 of you thought putting characters in a special sequence. Would you agree that that would be encryption? It's possible for encryption, yeah. I mean, if you talk about transposition, that is really what you do, and you just rearrange the characters in a certain order. So it could be seen as encryption, but if you compare the options, transform a message to make it immune to attacks is a more general option. So it's the better answer.
It's not never immune. You could always brute force.
Yeah, unless it's
Or a random thing.
yeah, or an quantum encryption, then you couldn't brute force it even. But yeah, let's talk about normal ones. Okay, Jonas still, second time in lead. Next one. Excellent. You did learn something. Okay. Jonas still in the lead. I have to take him down soon. Okay, next one. Great. Oh, you only need to get access to what they need and nothing more. Perfect. This is too simple. Still, but it's close. It's just in terms of seconds. Okay, next one. Okay, I just have to reply on the Slack here. Okay, let's see. A few talked about Internet Decryption Portal System. Does that exist? Maybe it does. I'm not sure. I mean, it's. We talked about cloud services and that you can put security as a cloud service, and then of course you can put encryption, decryption, some type on the cloud. So maybe you could build such a system and call it an Internet Decryption Portal System, but I don't think it exists today. Okay. Still very close. I think, yeah, 8 of 9. Oh, very even. Okay, what are the common factors? Why is this two-factor password PIN, why is that not correct?
Because it's redundant.
Yeah,
Authorization.
two-factor is just a way to say that we're using two factors. It's not one of the factors. We have to point to the possible factors. Password and PIN could be one factor, but two-factor isn't a general common factor. But something you know, something you have, or something you are examples of. Even if it's not precise, they are exactly what we talk about as common factors. Okay, could there be a shift? No. Okay, last chance now. Oh. Okay. Well, yeah, nothing is. Why isn't this blue one a good idea?
And they'll know you've read it.
They may send like random
Yeah.
emails, and then they'll know you're real.
As soon as you get back, they see that it's actually a working account. That means they will just send more. If you stay silent, they may drop that email after a while. So, I guess, yeah, Jonah, good work. So, this week you have tutoring sessions. There will be introduction of the third assignment. And on Friday, or on Thursday, we have a last lecture actually, full lecture on payment security. So I'll see you on Thursday then.
Is the introduction to that last today or on Thursday?